Guys, so today's lesson is on factoring and finding x and y intercepts of a quadratic with leading coefficient of 1. Okay, so remember, this is very important for you to remember. The process of undoing a distribution, okay, which means multiplication, is called factoring. Okay, to change a quadratic expression from standard form, okay, that looks like this, okay, b and c are just numbers, to intercept form, okay, things that look like this, that we have multiplied in the past. You can always use the magic x method to factor when the leading coefficient is 1, okay, when there's no number in front of this x squared. Okay, you need to remember that the x-intercept we find by setting y equal to 0, and you find the y-intercept by setting x equal to 0. And finally, remember that if you multiply two things and it equals 0, then that must mean that either the first thing you're multiplying must be 0 or the second thing must be 0. Okay, so, and the last thing you really need to, and this is called the product property of multiplication, okay? Here it is. Okay, so let's just do a quick example of what I'm talking about. So let's say you have something that looks like this, okay? Okay, so we gotta use the x to find the numbers that multiply to the last but add up to negative 21, okay? And the last one is negative 72 in this case. So we gotta write down negative 72 at the top, okay, numbers that multiply to negative 72, okay, but they need to add to negative 21, okay, so then you think, okay, this is where you have to think, okay, so it's, okay, numbers that multiply to negative 72, okay, so then you start with like 2 and 36, okay, but remember it has to multiply to negative, so this needs to be a negative number, okay, and why do I know the bigger one needs to be negative? Because you need to add to a negative number, so that means that when you combine these two you gotta get a negative answer, okay, so that doesn't work. Okay, what about 4 and negative 18, okay, and how am I getting these numbers? Well, I know that 4 goes into 72, but I don't really know how, so I just divide 72 by 4 and I get 18, but since it's negative, then it must be negative 18. Okay, when you combine these two, you get negative 14, but we're looking for a negative 21, so that doesn't work either. Okay, how about, okay, 3 and negative 24? Okay, do those numbers add up to, yeah, those are the ones that we need here, so we gotta put 3 and negative 24. These are the numbers that we have to use in order to transform this into our intercept form. Okay, so let's check it out. Okay, so now we go to step 2. So now those values that we find, okay, we gotta plug them into our, so we gotta rewrite our quadratic. This can be written as this, okay, as a multiplying form here. So then instead of writing, okay, we're gonna put the plus 3 here, put the plus 3 here, and the negative 24 here. Okay, so you have now factored the standard form into intercept form, okay, and why do we call this intercept form? Because it's so easy to find the x-intercepts when you have it like this, okay, so then, okay, so now we're going to use the standard form to find the x and y intercepts, okay, but remember, to find the x-intercepts, you have to do, okay, so we put x-intercepts, okay, we must say y equal to 0. Okay, so then you gotta write 0 equals x plus 3 and x minus 24. That's a 4. Okay, and remember what I told you up at the top, the zero product property tells us that if two things are multiplying and they equal 0, then either x plus the 3 has to equal 0 or x minus 24 has to equal 0. Okay, when you solve this simple equation, you subtract the 3 over, so you're going to get x has to be negative 3 or That's an OR. X, okay, add the 24 to the 0. 0 plus 24 has to be 24, or X has to be 24. Okay, so then the two x-intercepts we have are -3, 0, because x and y-intercepts are points, okay, so you gotta remember that. Okay, and the other one is 24, 0. Okay, but remember we have to find both x and y-intercepts. Okay, so in order to find our y-intercept, we have to set x equal to 0. Okay, we can still use this equation, or we can use the top one. Okay, it's up to you. You get the same thing. Okay, however, for y-intercepts, it is always easier to use the standard form. Okay, so I'm gonna use the standard form. So this is, okay, and I'll show you why this is always so much easier. Yeah. Okay, so this is the equation at the very top, okay, up here. This is the equation I'm using. Okay, remember this one and this one are the same, just written differently. Okay, so then we're finding the y-intercept, so we're looking for what y is. Okay, but we must set all the y's equal to 0, so we plug in 0 for all the x's. And remember, when we plug in numbers, we gotta put them inside parentheses. Okay, 0 squared is just 0. -21 times 0 is 0. So the y-intercept must be -72. Okay, and remember this is a point. Okay, where x is 0, so x needs to be 0, and the y is -72. Okay. So now let's look at how this is gonna look. We have all the things that we need to actually make this happen. Okay, and also in class I told you how a quadratic always looks like. Okay, a quadratic either looks like like a U or like an N. Okay, all depending on the leading coefficient. Okay, if the leading coefficient is positive, you're gonna get a U. Okay, if it's a negative, then you're gonna get an N. Okay, this is called concave up, this is concave down. Okay, so now let's see here. What do we have? So this is -3. So here we would have to, let me zoom it in so we can actually type these things in. Okay, so then on our graph we put -3, comma 0, and over here is 72, or not 72, 24, 0. Okay, and our y-intercept, remember this is our x-axis, so those are our two x-intercepts, and our y-intercept was 0, -72. Okay, and that's all we're doing right now. Okay, figuring out x and y-intercepts of a quadratic through factoring. Okay, through factoring to make it look like an x-intercept form. Okay, and that's all for now.